The purpose of this activity is to make sure that we get a better sense of how exactly the slope and intercept numbers work in these y equals mx plus b equations. Let's take a look at this first case. I notice that I've got 4 equations and 4 graphs. Our job is to match them up. Let's see what's similar. Notice how they all have at the end +3. That means these 4 lines all have the same y-intercept. And sure enough, they all cross the y-axis at the same height, a height of +3. I hope that makes sense. So the only difference is the slopes of the lines. In terms of how we can then differentiate them, let's break it down into 2 groups. I see here the red line is going down as I go left to right. The green line goes up, the purple line goes up, and the blue line goes down. So I think let's focus on the ones that go down first, because we know those will have negative slopes. So that's the red and the blue. As I'm looking at my slope numbers, there's a negative and there's a negative. So one of these is red, one of these is blue. To determine which is which, I'd like you to get used to the idea that smaller slopes give you flatter lines. So -1/2, that's less than 1, that's going to give you a fairly flat line. -2, the size of that number is bigger than 1, that's going to give you a steeper line. So as I look here, the red line is less steep. That's going to go with the slope of -1/2. The blue line is steeper. That's going to go with the slope of -2. Let's just check that, make sure it works out. So on the red line, to go from point to point, I have to go down 1, right 2. There you go. That's your slope of -1/2. Whereas on the blue line, I have to go from point to point, down 2, and right 1. And that's your slope of -2 on the blue line. Now for the positive slopes, the same reasoning holds. Small slope, meaning less than 1, flatter line. So that's going to match up with the green. Steeper slope, slope bigger than 1, that's going to match up with the purple. And you can again do the check. On the purple line, to go from point to point, I've got to go up 2, right 1. Whereas on the green line, I go up 1, right 2. So we get that slope of +1/2. Case number 2. Here, now it's the slopes that are the same. We notice that the x's don't have any numbers in front of them. That means they're really imaginary 1s. Every single line here has a slope of 1. So if your slope is 1, that means that you go 1 up and 1 right to get from point to point on the line. So any point on the line, you go 1 spot up, 1 spot right, 1 up, 1 right. So the only difference is the y-intercepts. Let's just look at where these lines cross the y-axis. The purple one crosses right here. That's at a height of +4. I'm looking for the +4 on the back. This is my purple line. Do a quick pause if you haven't already. I want you to try the other 3 and then unpause when you're ready to check. The green one, we cross the y-axis at a height of +1. So I'm looking for a +1 on the back of the equation. There's my green line. The blue line crosses through the origin. That's at a height of 0. So there'd be a +0 on the end. But since +0 doesn't change anything, we typically don't write it. So this one's going to be the blue line. And then lastly, the red line crosses the y-axis at a height of -2, 2 spots down. So we want that -2 on the back. There is your red line. In this next case, what we see is 4 lines. They again have the same y-intercept. +2, +2, +2, +2. They all cross the y-axis at a height of 2. The only difference is the slopes of the lines. Take a look at these numbers. 0.25 is the smallest. 0.5 is the one that's bigger than that. 1.5 is bigger than that. 2.6 is the largest. So the slopes go small to big. That means that the steepness of the lines is going to go from flat to steep. So this top line with the smallest slope should be the line that is the flattest. As I look at these, it's the red one that is the flattest. So my first line is my red line. The next bigger slope is going to be just a little bit more steep than the previous one. That's going to be the blue. As the slope gets bigger, the line gets steeper. So the next biggest slope should be the next steepest line. And then lastly, the steepest line, the purple, should have the biggest slope. Low slope flat, high slope steep. Now with these, you may want to reference your toolkit paper. There's two types of lines. We've got y equals a number and x equals a number. The y equals a number, these are the ones that are going to go straight sideways. The x equals a number, these are the ones that go straight up and down. So as you're picking, let's just run through them. The sideways line at a height of 3. Well, that's the red one. Height of 3, sideways line. Y equals -2, sideways line, height of -2. So this was at 3, this one's down at -2. That's the green one. For the x's, do a similar thing, but now we're looking at where they cross the x-axis. X equals +3, straight up and down through x equals 3. That's going to be the blue. And then straight up and down through x equals -2, that's going to be the purple. Now, one common error that students make when writing their equations is forgetting to put both the letter y and the letter x in the equation. I want you to see the difference. If I type in y equals 2x plus 1, we get a slanted line that crosses the y-axis at 1, and that has a slope of 2. So from point to point, you go up 2 spots for the right one, up 2, right 1. If you type this same equation without the x in it, you get something very different. Notice this purple line doesn't even have any tilt to it at all. The x in the equation is very, very important if you want your line to be tilted. Without that, it's just y equals a number, and y equals a number is always going to be a line that goes straight across. So just remember, when your line is at an angle, you need the y and the x to both show up.